All right, and I believe we're live. All right, hello, and welcome everyone. Welcome to the third and sadly the last of the guest lectures in the series for the class Introduction to Computational Design, taught here at the Harvard Graduate School of Design. It is my honor, my pleasure to welcome Behnaz Farahi, Dr. Behnaz Farahi, to this lecture today. In the series that we have been conducting this semester. I'm actually very happy to welcome her because, as many of you already know, it's this time of the semester in the class where we have already learned how to write code. We've already learned technology. We've learned a lot of three-dimensional geometry, but it's kind of the time of the semester where it's good to start inquiring on what all these techniques, how they can actually help us become better designers and open our minds to other fields that is not like the canonical parametric modeling, etc., etc. Also, all those things that we are a little bit used to. And in that sense, I think Behnaz's work is fantastic in illustrating how technology and computation can also be used as a tool for critical thinking and addressing issues in society, if I may. So I would like to welcome her to this lecture. I'm going to do a quick formal introduction. Behnaz is trained as an architect and is an award-winning designer and critical maker based in LA. She holds a PhD in interdisciplinary media arts and practice from the USC School of Cinematic Arts. Currently, she is an assistant professor at the Department of Design at the California State University in Long Beach, and she explores how to foster an empathetic relationship between the human body and the space around it using computational systems. Her work addresses critical issues such as feminism, emotion, perception, and social interaction. And she is the co-editor of an issue of Architectural Design, 3D printed body architecture from 2017, and Interactive Futures, one that is forthcoming. I believe she is, as of very recent, the recipient of the 2021 Cooper Hewitt Smithsonian Design Museum National Award for Digital Design. Am I correct, Behnaz? Yes. And we met at Acadia 2018 in Mexico, I believe, or at least that's when I first was aware about your work and the depth of it. So we've been working actually a lot lately in the organization of this year's Acadia, as many of you know, because you were participants. And it's been my pleasure to work with such a skilled and such a professional academic. I'm very happy to be here. I'm very happy that you're here. And I would like to give you the stage, Behnaz.
Thank you so much, Jose. It's a great pleasure to be here. Thank you for inviting me. So with that, I'm going to share my screen.
And before I forget, we will have Behnaz's lecture right now, and then we will open it up for Q&A. I will start with interventions here from the people who are on the Zoom call, Harvard affiliates, and then I will be monitoring the chat for those of you who are live on YouTube right now, and I will relay your questions later on to Behnaz. Okay? Thank you, Behnaz.
Thank you. The topic of the talk today is critical computation and emotive matter. So I'm going to start this presentation with giving a little about my background. I am from Iran and I started to study architecture from 2003. After I received my master's degree in Iran, I moved to US to study my second master's degree in architecture at USC. And after my master's degree is finished, I started studying my PhD in media arts and practices at USC School of Cinematic Arts, in which during this time I started developing series of works that situate in the intersection of architecture, interactive design, fashion, and really beyond. With that, as I'm going to start. As someone who has been always fascinated about tactility, textures, and movements of materials, I've been always really interested to see how we could embed computational systems into the substrate of the matter, as though materials become machines and machines become materials. But perhaps a new kind of machines. This is what I call an emotive machine, or emotive matter. And what I mean by emotive matter is developments of bio-inspired material systems in order to address larger psychosocial issues related to human emotion or bodily perceptions, or in fact, social interaction. And in that, I have to say that I am extremely inspired by nature, not only in terms of its beautiful morphologies and its complexities, but also in terms of its complex behavior, in terms of sensing and actuating capabilities that are tightly coupled to one another. So I'm interested to see how, for instance, materials of the environment could become alive and respond in a similar fashion to their surrounding environment. So I started exploring this in architectural installation scale by producing series of interactive walls and interior spaces in which they change shape and reconfigure, and they're soft. They're usually made of textile and stretchable fabrics with some components that they're pushing and deforming these type of surfaces. But also the other intention was really to see how we can develop an intuitive interface between the human body and the physical form of the environments in order to create a sort of reciprocal relationship between the shape of the environments and the activities of the people in the space. For instance, this robotic ceiling installation is responding to the movement and activities of the people underneath the ceiling, in order to create that type of reciprocal relationship. This was part of a research collaboration that I was part of at USC Media Arts Memo Lab. But this type of investigation didn't stay just in the world of architecture. I was really soon interested to see how these ideas, how this technology could be populated around the human body, and how they could influence communication, human perceptions, and really sort of understanding how they kind of enhance or augment human capabilities. So I started doing series of 3D printed, what I called body architecture, in order to investigate how these architectural forms could be populated around the human body, and how these technologies would change human physiological and mental being. I want to walk you through a little of my research. Part of my research is about new material developments. In that, I look at various computational systems in order to produce materials that they change their properties across the surface, from soft to hard materials. So through computational system, you're able to control not only the material features and geometrical features of the materials, but also material properties in order to specifically specify which part of the surface is soft and which part is hard, and then using various type of actuation systems, such as a smart material like shape memory alloy, or pneumatic systems, or conventional systems such as motors and servos. You can activate the materials to have this dynamic behaviors. So a lot of this process engages with various type of digital design, digital fabrication techniques, and really trying to understand material behaviors in order to design a specific behavior according to what the material could afford in terms of its dynamic behavior. Specifically, I'm inspired by skin systems such as feathers, scales, and hairs. And I have developed a series of projects that try to develop a better understanding of the morphological and behavioral principles of these type of systems. For instance, these are scale-like prototypes 3D printed using object polyjet multi-material 3D printing, in which materials consist of not only one material properties, but variety of soft to hard materials. So as you pull the prototypes, they open up or change their properties accordingly. In this case, you're seeing a prototype where the two ends of the prototype are hard material, and as you get to the closer to the center of the surface, the material is softer. I have spent a lot of time with multi-material advanced 3D printing to explore various type of forms and geometrical features in order to specifically control dynamic behavior. But these materials and these 3D printers are extremely expensive. Some of the machines that printed some of the previous prototype that I showed, or in fact the one on the right, it cost about $250,000. So for me, part of my research also look at how we could develop materials using material geometries in order to control material behavior. Interestingly, not only material properties affect behavior of materials, but also very much about how we configure or geometrical feature of the material could affect the properties, the global properties of the matter. Interestingly, we find out that if you're using SLS 3D printing, which is a very, very fragile material, and you 3D print it in the form of coil, this material, the result is very flexible and dynamic and resilient toward any type of forces. So this was a sort of an exploration a few years ago with my collaborator, Pauline van Dongen, who is a fashion designer, to really explore various forms and various sort of formal expressions that we could explore around the notion of a spiral or coil. So to just kind of recap this section of my research, I look at material morphology in terms of their material properties as well as geometrical feature. Simultaneously, I look at the behaviors of materials, and in that I look at how materials could sense, how they can encode, and how they can respond to their surrounding environment. The second part of my research is looking at sensory technologies, in which I look at variety of both commercially available sensor technologies as well as DIY components that I can find available in order to read physiological responses from the users. Those information could be facial expression tracking, gaze tracking, or a sort of gyroscopes, various type of biometric sensors that can read these type of physiological responses from the users. And in that, I have to say that I'm very inspired also by the work that has been done at Affective Computing group at MIT Media Lab, directed by Rose Pickhards, in which the attempt is to really see how computational systems could recognize, interpret, or simulate human emotions through measuring some sort of physiological responses from the users. Whether that is successful or not, that's a different question, but that is something that is really extremely interesting for me to see how computation could actually understand human emotion. And maybe within this context, I would like to sort of share one of the projects, RedeSense, which was commissioned by Museum of Science and Industry in Chicago, and it still is on the display. So if you go to Chicago, it's still actually on display. And this piece, was very interesting because it was very challenging from technical perspective. This piece was inspired by hummingbirds. Hummingbirds are amazing creatures that they change the color of their feathers with the twist of their heads in order to attract mate. So they change the colors from dark green to pink magenta. So I've been really fascinated by this color and shape-changing properties of materials. And I've been thinking how I could produce a variable that could respond to its surrounding environment in a similar fashion by changing shape and color. And the first question was, how could we develop such a system? How could we make a system that is robust enough? Because the exhibition was, it started in 2019 for 1 year. The exhibition was 1 year, 9 a.m. to 5 p.m. every day. So one of the very pragmatic questions was, how do you develop a kinetic, shape-changing piece that is robust enough that can run every day? So from technical perspective, this was one of the big challenges, that how do you come up with a system that it's robust enough, that it's able to provide series of
Did Behnaz freeze? I believe she's frozen. Okay, let's give her a minute. Maybe there's something with her connection going on. Yeah, let's give Behnaz a minute. Oh, there she is. There you go.
My apologies, my internet completely dropped out.
No problem.
Let me share my screen.
I think you froze when you were playing with the MIDI controller.
MIDI controller, where was the MIDI?
Yeah, I think before that, yeah, over there, a little past that, yes.
I'm gonna play from here.
Yeah,
I hope this is okay. So, so one of the challenge was, how do we come up with this robust system? We decided to produce these items in-house with using electromagnetic mechanisms to really prototype a simple one-axis movements for these actuators. So this was extremely challenging task because to fine-tune this magnetic force in order for these materials to lift up the color-changing paper. It sounded simple in the beginning, but it went through many iterations for prototyping these components. At the end, we were very happy with the results of these actuators because we were able to control specifically how these components sit on the overall design using USB connections. So you will see the assembly of these components in a second. Every single actuators was consist of these many components, but we were able to provide extra components for the museum staff. So in case one of the components break, they can easily just take it out and replace it with one of the other components. One of the aspects of this project was everything in this piece, from electrical to mechanical to software. Every aspect of this project was actually custom made, and we were able to precisely control their behaviors. obviously, as you can see in this video, it was extremely labor intensive. I mean, it was 250 actuators and lots of wirings, 40 driver boards, I think 4 microcontrollers, 1 camera. They were all embedded inside this piece. And the camera that is embedded inside the piece could see the people around. And according to their facial expression and the location that they're standing in front of the piece responds accordingly. So if the person is angry, the piece starts to move with a very fast, jittery movement to almost repel the viewers to get closer to the piece. Or if it detects that you're happy, it generates sort of a very smoothing ripples of movements across the surface. Conceptually, this piece was really kind of engaging with the notion of sensory substitution. So if your eyes are closed as a person, if you're visually impaired, you could basically hear the emotion of the people that they're expressing through their facial expression, even with your eyes closed. And then as the last section of my presentation, I want to talk about the last part of my research, which is related to the notion of critical computation. In fact, along with Jose, I was one of the co-chairs of 2021 Acadia conference. Acadia, for those of you who are not familiar, is the Association for Computer-Aided Design in Architecture. And this year, our theme was realignment toward critical computation, where we introduced the notion of critical thinking to the world of computation. So with that, I'm going to share a 15 minutes video that in which I will explain more the theoretical discourse that it's really pronounced in my own work. And then after that, I will open up to Q&A. So let me make sure I share the sound. Oops. Where we are immersed in the world of machine learning algorithms, computer vision, and biometric sensors. But what does this all mean? Might these computational systems not replicate, somewhat disturbingly, our underlying biases and serve to reinforce the marginalization of those who have typically been excluded? Is AI necessarily complicit in replicating human prejudice? Or are there ways of deploying AI as a means of exposing human bias? I would suggest that there are potential strategies that could be deployed for AI to actually overcome bias. In this presentation, I'm going to address notions of the gaze, surveillance, and ways of seeing through the lens of my own creative practice. By implementing computer vision technologies, I hope to examine how different strategies of the gaze can be seen to undermine various forms of power structure and to promote forms of resistance. Here I'm trying to avoid any form of technological determinism. Rather than rehashing arguments as to whether surveillance is good or bad, I hope to take an intersectional feminist approach to show what constitute the gaze and surveillance, and to consider what the strategies of resistance might be proved to be effective in art and design practices. In my work, I have used various computer vision technologies to enhance human perception. For example, this is an emotive wearable which can recognize and respond to the facial expressions of people around with different type of behaviors. This type of smart, soft robotic garment could potentially benefit those with autism who have difficulties recognizing facial expressions. Another work, RedeSense, is an emotive collar equipped with a facial tracking camera and an array of rotating quills, which respond to the movement of onlookers and their facial expressions. Similar to how a blind person could sense through haptic information, the movement of the wearable would allow the wearer to sense where people are standing and the emotions they're expressing, even with her eyes closed. Here I hope to address two questions related to the notion of the gaze. Firstly, what does it mean to be observed? Secondly, what do we see when we look out at the world? Through my argument, I use gaze as an interchangeable concept which could be shared between human and machine. This takes us to the historical concept of Panopticon. The Panopticon refers to a type of institutional building and a system of control envisioned by English philosopher Jeremy Bentham in 18th century. The layout of the Panopticon allows a guard to observe occupants without them knowing whether or not they're being watched. French philosopher Michel Foucault revitalizes interest in the Panopticon in his 1975 book Discipline and Punish, and uses it to illustrate such a model could be applied to disciplinary societies in order to control their citizens. He described the prisoner of a panopticon as being at the receiving end of asymmetrical surveillance. As a consequence, the inmate polices himself for fear of punishment. What is fascinating about this example is that rather than external actions, the gaze of the watcher is internalized to such an extent that each prisoner becomes his or her own watch person. Similarly, we could argue that this is what allows rules and regulation to be internalized so as to inform our actions, behaviors, and even our beliefs. Moreover, the manner in which we naturalize and internalize rules, it could be claimed, causes society to be less willing to contest unjust laws and accept a dominant outlook. Similar to how the inmates are not aware whether or not they're being watched, we are not aware that we have been controlled through naturalized dominant rules rooted in our own culture. This internalized asymmetrical power structure could be seen in the notion of male gaze. In her essay on visual pleasure and narrative cinema, Laura Mulvey exposes the asymmetry of social and political power relations between men and women. Mulvey claims that the male gaze serves to depict women as the object of pleasure for the heterosexual male viewer. Besides the fact that women are regularly subject to sexual harassment whenever they enter public space through various forms of looked-atness, women have absorbed all this unconsciously as a form of internalized male gaze. What if women were to subvert this through the power of their gaze? Could we draw upon computer vision technologies to allow women to know when onlookers are staring at them? Augmented with facial and gaze tracking technology and smart materials, this cape responds to the onlooker's gaze. The project engages with broader social issues such as the male gaze on the female body. The facial tracking algorithm in this piece detects age, gender, and gaze of the onlooker. While we know that gender is performative and it doesn't depend on pure representation, the movement of the garment based on the viewer's gaze could unfold a new sets of social meanings. If you are the wearer, you know which part of your body is being looked at, and if you are an onlooker, you know that your action is being noticed. The aim is to see how different strategies could be used to undermine the patriarchal system by developing a form of resistance using surveillance technology. I wonder, what do we see as we gaze out to the world? As a thought experiment, French psychoanalyst Jacques Lacan invites us to envision ourselves before a female mantis. The female mantis is known for devouring its partner after sex. In Lacan's experiments, we're wearing a mask, and we do not know whether the mask represents us as a female or male, and therefore we don't know whether or not we will be eaten by the female mantis. We simply do not know what we are to the other, and we often project our own very biases to the other in order to understand the other. In fact, we don't see anyone as they are, rather we see them as we are. And how we are is informed by the conformity to many of behavioral assumptions dictated by laws and customs. Although the colonial, racist, and sexist gaze might project oppression, backwardness, and terrorism onto the image of Muslim women wearing a burqa, I would like to stress the inherent difference between a mask and masquerade. While the mask hides, the masquerade reveals, but perhaps we could suggest that both are acting to some extent as a shield against the intrusive gaze. This project is inspired by the historical mask worn by Bandari women from southern Iran. It has been said that these masks were developed during Portuguese colonial rule as a way of protecting the wearer from the gaze of a slave master looking for pretty women. From these Iranian masks protecting women from the patriarchal oppression, to masks of Northwest Coast Indians, to masks worn as political statements, masks take on a range of different religious, social, and political roles, and offer an interesting insight into how we could use them to either conceal or reveal our identities. While these Iranian masks cover most of the wearer's face except the eye, I've been wondering how the eyes could be used as an expressive medium for communication. In my research, I came across an interesting incident in which an American officer uses blinking to send a secret message. In this video, you're seeing Admiral Jeremiah Denton blinking the word torture using Morse code during his captivity in Vietnam.
What's so-called definite law. Do you think that's present about?
Well, I don't know what is happening. But whatever the position of my government is, I support it fully. whatever the position of my government is, I believe in it. Yes, sir. I am a member of that government.
The use of code for communication is nothing new, and in fact, women came up with a code word as a method for reporting domestic abuse during this lockdown. In this project, I was particularly inspired by a recent experiment involving 2 AI bots at the Facebook AI lab. The intention was to monitor how 2 bots might develop a dialogue. However, during this experiment, the bots seemingly started to formulate their own language, a language that no human could understand. The researchers had to intervene and tweak the algorithms to prevent this from happening. The story could also reveal how knowledge is power, and inability to understand unnerves those who wish to maintain their authority. For the source text of this project, I used the seminal article, Can the Subaltern Speak?, by the feminist theorist García. She asked whether it might be possible for the colonized, or the subaltern, to have a voice in the face of colonial oppression. Using machine learning algorithm, we can use Markov chain to create a text. We represent each word as a state and view transitions as the likelihood that a specific word might go after another. We can consider these states at either a word or character level, and we can analyze what the probability might be of a given letter appearing after 3 letters. The engrams of a given text provides a strategy for generating the next text. The Markov chain could be therefore used to generate text where each new letter is dependent upon the previous letters. As the mass communicates using BLE protocol, the algorithm is repeated and the engrams changes. The smaller the engram gets, the less meaning there is in the generated text from the linguistic perspective. Each letter generated through this process is translated into Morse code, which informs the movement of the actuators. In the video documentation of this project, which will be shown shortly, you will see 2 women wearing masks, covered with eyelashes controlled by AI. They begin to communicate with each other, blinking their eyelashes in rapid succession. The aim is to develop a secret message for transmitting information between multiple women. The project brings together design, critical thinking, feminism, and AI. Winston Churchill once said, "We shape our tools and thereafter our tools shape us." But doesn't this suggest a form of technological determinism? After all, there is no inherent application for any tool. A knife could be used as a murder weapon or just as a tool for cutting an apple. Similar arguments could be made about surveillance. The question we should ask are, in what context, how, and for whom are we using it? We should be aware of potential problems with AI. For once an issue is recognized as problem, it becomes a different kind of problem. It becomes a problem not by which we are trapped, but rather with which we can deal. Bias is certainly a problem which originates from human beings and is replicated and even exacerbated in AI. As we are training the artificial algorithms to learn to see the world, it is important to ask ourselves, what does it mean to be seen by the machine? And through the lens of what kind of data are they trained to look out to the world? Thank you, everyone. I think with that, I would just looking forward to any questions or discussions you might have.
Can we please give Behnaz a digital applause before we move into Q&A? Thank you very much, Behnaz. That was amazing. It was literally mind-blowing. Thank you. I'm going to open it up to questions first here on the Zoom call, and then I will relay a couple of questions that I found on the chat. But while people perhaps think about questions or phrase them, I would like to start saying that I was very fascinated. I am constantly fascinated by the depth of the work and what a critical perspective you bring into it. I have been following your work, but I think it's the first time that I have this consistent exposure to your narrative and the story that informs all of your trajectory, which I find fascinating. I do believe that the link that you make with established philosophers and feminist theory, it's actually quite interesting in the light of all the developments that we are witnessing in artificial intelligence, surveillance, etc. I think in that sense, I could be talking about this for an hour and a half probably, which we don't have time for. I'm also particularly fascinated about how a lot of your work is trying to explore the idea of how surveillance is basically this prevalent, omnipresent fear or this burden that we all suffer. And this is particularly prevalent in the case of women and in the case of the male gaze, especially when there's sexual connotations and when there's a phallocentric culture around this, and all the inertia that we have been following across many decades and centuries. And I like how I think you mentioned the idea of us feeling in the receiving end of an asymmetrical surveillance, and with the Panopticon as this metaphor of being seen but not seen, right? In this sense, your work is very unidirectional because you are worried about the idea of surveillance and the idea of gaze in particular as a form of surveillance. Have you, during your work, explored the idea of surveillance within ourselves? I guess what I'm saying with this is many of your objects, many of your wearables have these cameras that are pointing at what's happening outside, and they give us physical, wearable, affective notice of what's happening outside, to a point where these objects almost respond automatically with some pre-programmed reactions, whether if we can call that your bias as an artist, or if there's freedom for the user to customize the behavior of this. But I wonder if you've ever considered the idea of surveilling ourselves, so sensing ourselves and trying to find perhaps things that we don't notice about our emotional states, our physical states, and if even doing that, you would consider that a form of surveillance. And I guess when I'm saying this, I think I'm giving it a negative connotation. Would that be a form of negative surveillance towards ourselves, in the way much of your work is a form of resistance towards external surveillance? Any thoughts around this?
Also, that was amazing. I mean, I really enjoyed actually this question. I mean, there's so many aspects in it that I feel like I can go on from different angles to answer this, but I really actually enjoyed your question. It is true that many of my work look at the notion of surveillance from almost the perspective of seeing as a strategy of resistance against some external action, right? So it is true that in a lot of them, that's mainly what is happening. But I also have done series of works that look at, for instance, other types of sensors, for instance, brain-computer interface in which the user's brain activity map to some behavior. I mean, either that person could control the physical shape of the objects that she's wearing. And I think from that perspective, I mean, BCI research is really fascinating for me, because it really blurred the boundaries between our biological body and the outside world. To go back again to your question, I think the question of like, why am I this fascinated by this notion of surveillance as a form of resistance? I think it's something for me to think more about. So I don't know if I can exactly answer what it is that it's keep taking me there in that direction. But I think the ultimate scenario really is to have both the physiological responses from the users as well as information from the outside, like social interaction, be mapped as a matrix of information that can inform the next action. That would be sort of the ultimate goal. Is that still a surveillance? I think so. I think I also agree with Benjamin Bratton that our notion of surveillance needs to change. I mean, surveillance perhaps is no longer just a control mechanisms, but any technologies that could see inside our bodies or outside our bodies could be called as a form of surveillance, if you like to call it that way. The sensors that you wear in the time of pandemic to track your temperature or oxygen level in your blood, things like that could be seen as a surveillance and could be controlled by authorities and the governments. On the other hand, it could be a way for you to take care of your loved ones, right? So it's always this question of what do we call surveillance? And if we call it surveillance, is it a bad thing or is it a good thing? And can we avoid this type of naming them, are they good or bad, and really see what kind of possibilities they would provide for our daily life. And maybe I just say one more thing, and that is the fact that I think from that perspective, I mean, I'm excited about the course you're teaching, Jose, because I think like the computational design, especially for students, is like getting your heads around a lot of computational technologies, which is a really broad topic still. But the next step is what do you do with them, right? Like, so now imagine you are a computational designer. What do you want? What are you planning to do? What are you planning to say with these technologies? And I think that's where things are getting really interesting.
I could not agree more. I'm not going to ask you to say that again to this group, but like I would like the group to really sing that in. We become computational designers, we master the skills or whatever, but then what do we do with them? That's the big question, and that's where critical conversations around society around what is the role of AI, what is the role of dominance, what is the role of the patriarchy, and how can we respond to that with technology is where those questions become really relevant. I would like to open it up to questions here on the Zoom call first. So if you have a question, you're welcome to unmute yourself and run your question by Behnaz. I'm getting requests here in the chat. Katarina, you're welcome to jump in.
Hello. Hi, Behnaz. Nice to see you. Can you hear me okay?
Mm-hmm.
Yes.
Okay. Well, I'm, a little biased because, my work looks at yours incredibly in terms of inspiration, but I'm curious to I would love to pick your brain in terms of maybe where you see the future of your work going, and specifically also, I think there's this projection of what is the future and in terms of scale, and I'm curious to get your perspective if you think that we're going to remain in a more body-centric scale when it comes to working more on the psychophysiological scale of looking at how people are responding to our environment, or do you think this is actually going to transfer to a larger scale, as in the built environment and the spaces that we live in? Where do you think your work might position itself in the future? So, yeah.
Thanks, Katrina. That's a great question. I think the question of scale is definitely interesting because I studied architecture and then I moved to sort of doing more wearable and fashion, to the point that everyone thought that I'm a fashion designer. And I was like, no, I'm not a fashion designer, right? I'm not, I am interested in a scale of wearables because you can address so many things related, as you mentioned, about physiological responses from the users. You could get theoretical around the human perception, and there's so much to tap, and there is so much conversation around the user or the person you're designing for that it's so immediate, and that makes me really excited about that scale. Having said that, I am excited about sort of scaling up back again and sort of see that how this type of systems could be applied to a larger scale, either in terms of installations or public arts installations. That's really something that I'm more interested to move in future. How such systems would allow for collective gathering of information is another type of questions that, for instance, in RedeSense, we were getting average of people's affective, emotional expressions, and having the piece respond to the average of the information that it captures from multiple people in the room. So how do you account for collective informations that you're gathering in the public space is something that is interesting. And what does that mean? And the question of privacy has become another issue, right? Because when you're designing something for one person, the question of privacy, again, is very immediate, right? With the consent of one person, you fine. But the moment you go to public space and you're dealing with gathering data, then the privacy has become another critical issues. So for me, obviously my work is getting different turns as it's evolving. And I am happy with that. I think the fact that I sort of like starting from bio-inspired design and gradually move towards sort of critical computation, and really opening the ways that the world of computation could address larger issues is exciting for me. So where does it go next, and what kind of critical issues I would be interested is something that is evolving. I think I'm more and more interested in addressing also related to environmental crisis, but not precisely just environmental, but I am interested in the intersection of social and environmental crisis, where these two are entangled in one. So it's super fascinating to see like how these two also are related. So, and I know that you're really interested in the world of, let's say, affective computing yourself. And I am absolutely still interested in that. But I also think that there are many other aspects of sociopolitics that it's a little absence in the current state of affective computing discourse. So I'm really interested to see how those layers could come back to the notion of affective computing. What does it mean to experience certain emotions if you're part of certain social groups or social class? So those are areas that I would say I am interested to see how my practice move toward more and more.
That great answer. Thank you so much. Yeah, I totally agree with with the perspective. So good luck moving forward. Excited to see.
Thanks. And I'm obviously excited to see where you're going. So keep me posted.
Thank you, Katarina. I'm going to open it up to questions also from the YouTube live stream, and I can relate to you like a wealth of emojis in the form of like hands like this, clappings, wonderful smiley faces, 100 signs. It's you will be able to go over the whole list, or sentences such as "this was truly inspiring," or "that was amazing work," etc., etc. There is a question from Andres Roncal where he's asking if, do you see the possibility of tapping into the nervous system similar to biomechatronics? I don't know why Stellar just popped out in my mind right now with that question.
Yeah, I mean, I guess Stella could be interesting relevance, but also I think, I mean, most recently you see the in Neuralink that you see the monkeys are actually able to control the environments or play the game of ping pong by the power of their brain. That is where I think the future is sort of, we are going in that direction. How we could find the sort of very much immediate connection to the world around ourselves. And I'm not necessarily interested in plants, but I'm certainly interested in BCI research, brain-computer interface. How could you control outside world with the power of your brain? It's something that is definitely tap into also like human nervous systems, how the world outside our bodies could become an extension of one's. And it just opened up so many possibilities. Again, I'm really interested to see where are the blind spots in this as well, like where are the problems that we could find around it, or where are the problematic issues around it. But I think just as a sort of new area that I think it's growing really fast, I think the area of neuroscience and computational design is very, very interesting.
I agree, absolutely. I would also like to relay, this is probably the last question because I know you have to go, you have some teaching to do, and I don't want you to rush through it. But Mitra Baghetti is saying how amazing your work is, but she's also wondering what would happen if somewhere wearing some of these devices appeared in a crowd.
That's a big question. Like, what would happen if someone wear it in the crowd?
Or what do you think? What do you think if people? What do you think would happen if people wearing this would show up in a crowd?
Yeah, I mean, I think this type of projects, their role is not to be sort of ready to wear product. They're not going toward the mass production. As a designer, I see my role to ask questions through my work and challenge dominant outlooks, but not necessarily, I've never been a designer that I was interested in mass production or producing ready to wear items that you can wear on daily basis. Obviously, this become a question for those who are interested in the business side of things, and they're interested to actually take this type of innovation to the market. Honestly and personally, this never was my interest. So I kind of rather to stay in the world of speculation and imagination for what is coming for the future of computational design. And that's way more exciting space to operate.
Beautiful. Behnaz, I think with that, I'm going to wrap this up so that you can take your time to go back to class and teach. Thank you very much, like really, for being here today, for wrapping up this series of guest lectures this year. I think it was a really amazing presentation and interesting conversation afterwards. And I hope to see you around more often.
Thank you so much, Jose, for inviting me, and looking forward to see more of your work. Thank you.
Thank you. Can we give her a final applause? Thank you very much, Behnaz. Have a good evening. Bye-bye.